Welcome to Lesson 8 of Cron Mastery, the one where we make sure your jobs never, ever run twice. Because here's the production reality. A long job overruns the next tick. The same cron lands on two boxes. Somebody manually reruns a failed backup while cron fires anyway. Running twice is worse than zero, and the fix is a tiny pattern. Flock-n on a lock file. That's the whole game today. Idempotency and locking. Here's the map for the next 30 minutes. We're working two complementary tools, Flock, which is your technical mutex at the kernel level, and Idempotency, which is the logical safety net in your job's own code. Flock is one word on a cron line. Instant protection. Idempotent design takes a bit more thought, but covers the cases Flock can't. We'll handle stale lock paranoia, and by slide 7 you'll have a decision tree for picking the right tool per job. So let's make this concrete. Job A kicks off at 3 a.m. and takes 7 minutes. But Cron doesn't know that. So at 3:05 it cheerfully launches Job B. For 2 minutes, you have two backup processes hitting the same database and writing to the same files. The fallout splits 3 ways. Partial writes leave you with interleaved garbage that's valid as neither backup. Your DB grinds on lock contention until one job times out, and the other finishes on stale data, and at the business layer, you've just charged the customer twice. This is what running twice actually costs. The good news is, the fix has been sitting in your distro since 2006. Flock wraps your command in a kernel-level mutex, 3 pieces, that's it. Flock is the wrapper, -n means don't wait, just bail with exit code 1 if someone else holds the lock, and the path is just a file you pick. Kernel releases it when your process dies, so there's no stale lock to clean up, no PID file dance, no cleverness required. Let's prove it works. Open 2 terminals. In the first one, you grab the lock and hold it for 30 seconds. Script starts working, prints its output, exits cleanly, lock auto-released, exit code 0. Meanwhile, in the second terminal, you fire the exact same command. No output. Returns instantly. Exit code 1. The kernel just told you. Someone else is already doing this, you're done. That's the entire contract. And it's the contract that keeps your job from running twice. Now, locking is only half the story. Locking stops 2 runs from colliding. But what about the run that crashed halfway through, and Cron retries it 5 minutes later? That's where idempotency comes in. Look at the left, append to log. Run it twice, you get 2 entries for the same count. The history is now a lie. On the right, same query, but you overwrite a single state file. Run it once, twice, 100 times. The file always reflects reality. One pattern corrupts on retry, the other heals on retry. You want the second one. So how do you pick the right tool? 3 questions, that's it. First, could this job ever overlap with itself? If no, you still owe it idempotent design, because retries and manual reruns will happen whether you plan for them or not. If yes, ask the second question. Same box, or could it land on different hosts? Same box? Reach for Flock, kernel level, free, no cleanup. Different hosts, Flock is blind across machines, so you need a distributed lock. Radis CTNX, console, etc. Cheapest defense that actually covers your blast radius. Nothing more, nothing less. Now here's the question that reframes everything. Why is running twice actually worse than not running at all? They feel symmetric, both are bugs, but they aren't. And there are 3 reasons. 1, a skipped run is loud. The next cycle, your monitor or a missing log line catches it, and the damage is bounded by work that simply didn't happen. 2, a double run corrupts silently. By the time a customer complaint surfaces, the bad state has already fanned out, and restoring from backup won't undo the side effects. 3, idempotency is recoverability. A job anyone can safely rerun at any time after any failure turns Cron from a scheduler into a self-healing system. So here's your cheat sheet. Print it, tape it next to your monitor, and stop Googling flock flags at 2 in the morning. 3 columns. The flock options you'll actually reach for, the idempotency patterns at the SQL and shell level, and the production cron lines you'll copy-paste for the rest of your career. Notice the pairing, a lock on the outside, an idempotent operation on the inside, belt and suspenders. That's the whole game. Cheat sheet's nice, but you don't actually own this until your fingers have done it. 3 drills. First one, race 2 flocks in parallel terminals and watch the second one bounce with exit code 1. Second, hold the lock, sig-kill the process, and prove to yourself the kernel cleans up, because that's the question that wakes you up at 3 a.m. Third, take a log-appending script and make it idempotent with 1 well-placed redirect. 30 minutes total. Do them tonight. Now, the landmines. 5 patterns that look like locking but quietly aren't. Forgetting dash-in means flock waits forever, and an hour later you've got 60 cron instances stacked in queue. Check then act with a test F is a textbook race. 2 processes, both see nothing, both proceed. Cleaning lock files at boot? You just orphaned a held lock and invited a duplicate run. Flock over NFS degrades to FCNTL and lies across hosts. Use Redis or a real distributed lock. And an unset lock file variable silently flocks on an empty string. Every one of these has shipped to production. Don't let yours be next. That's lesson 8. 4 things to carry with you. Flock-in is your default. The kernel cleans up your locks when the process exits. Idempotent means safe to rerun, and running twice is always worse than running 0. Next up, lesson 9. What happens when the machine is off at 3 a.m.? Anacron, persistent timers, and catch-up runs. See you in the next deck.